4-5 Scatter plots and lines of fit. Data with two variables is called bivariate data. So think of bivariate, and when we hear bi, we think of two. So two variations of data. A scatter plot is a graph in which two sets of data are plotted as ordered pairs in a coordinate plane. And so typically what we see when we see scattered plots is the dots are kind of scattered. That's why it's called a scatter plot, all over the graph. They're not necessarily in a specific straight line or a consistent area. So when we are evaluating correlation, there's three types of graphs that we can have. We can have a positive correlation, and this is when the dots on the graph are going in that positive motion. So they don't necessarily create a line, but they are showing correlation that's going in the positive direction. We also have a negative correlation. So this is when all of those dots are kind of forming in a random way, but they are going negative. So they are descending. And then the last correlation we can have is no correlation. And this is when the points of a scatter plot are just kind of randomly all over the graph, and there's no correlation, whether positive or negative, that you can see in the data. We can use scatter plots to see a trend in a set of data. So when the data points all lie close to a line, we can have a line of fit or a best fit line. So what you need to do that is you have to make a scatter plot of your data. So I'm just going to make an example of a scatter plot. You need to determine the relationship that exists. So you need to determine, is it positive, is it negative, what's the direction in which the line needs to go. So in this graph, we have our scatter plot, we have our relationship, it is positive, and then you draw a line that seems to pass close or through most of the points. And it doesn't necessarily have to touch every point, but it is a straight line. So I always suggest using a ruler when you're using best fit lines, because you want a straight line to kind of demonstrate with. So for this example, I would probably make my line go through about here. You want kind of even number of points on both sides of the line. So in this example, we have 1, 2, 3, 4, 5, 6, 7, about 7 or 8 on this side, and 1, 2, 3, 4, 5, 6 on this side. So we could have possibly made the line, we could have made it a little bit different, and we could have gone more like this, and it would have been a little bit more even. But you want to kind of stick to your numbers and try to make a line where you have even number of points on both sides of the line. Then from there, you can use 2 points on the line to write an equation for the line, and then you can use the best fit line to make predictions of what will happen in the future. You're going to be using your slope form of y2 minus y1 over x2 minus x1, and then you would be using your point slope form or your slope intercept form to begin estimating. I think the best example for line of fit is on page 246, and it is real world example number 2. I do encourage you to go and read through the roller coaster example and look at the steps that they have followed to solve the approximation determining the number of vertical drops a roller coaster would have. We're also going to take a look at different kinds of data and where they're located. So we have 2 different types of ways that we can predict values. And a linear Extrapolation is used to predict values outside of the range of data. So if all of your data is in kind of a smaller area, so if we had a graph and most of our points were up in here, so you could see that it's a positive relation, but all the data is grouped together. If you were trying to find an estimation that was outside of that data, that would be called a linear extrapolation. And you may have seen some of that in lesson 4-2. You can remember that it's outside because it's extra. So anything that's outside of the data is extra information. Then we can have a linear interpolation is used to predict values that are inside the range. So think of inside the range, so numbers that fall within the group but are possibly not graphed. So if we take a look at this example here, it says use the graph and equation below for the line of fit to estimate CD sales in 2015. Well, the graph gives us to 2007. So that means that we would be looking for linear extrapolation because you're looking for extra information that's outside of the range. The equation there is y equals negative 500x plus 13,215. So they're using x to represent the number of years. And so what you would do is you would replace the year for x. Now, what's tricky here is it's not the whole year, so it's not the 2007 or the 2015. It's actually just the end year. So just the 15 plus 13,215. And when you solve this out, you get y equals 5,715, and that's in terms of $1,000,000 would be your estimated sales and CDs in 2015. There will not be a lesson review for this unit. I do encourage you to do maybe 2 or 3 of each type of problem. So you may do closer to the 15 range in these examples because the easiest way to learn them and learn this process is by doing.